Clausius inequality is applies to any real engine cycle and implies a negative change in entropy on a cycle. The entropy given to the environment during the cycle is larger than the entropy transferred to the engine by heat from the hot reservoir. Clausius inequality suggests us that the criteria for reversibility and irreversibility of thermodynamic cycle. Integral cyclic integral of the change in entropy is reversible system is zero, and for the irreversible cycle its value is much less than zero. It should be done for the time system, and the system undergoes only reversible process or cycle if a cyclic integral equals to zero, and irreversible process or cycle is less than zero. That means uh, if the system is reversible, it equal to zero, and if it irreversible, it must less than zero. So inequality of Clausius can be determined by integral cyclic integral delta q over t less than zero. It is for irreversible system, and for reversible system it equal to zero. So both of them can be determined by this this equation.
So this is the application for the Clausius inequality. So one of the application that use Clausius inequality is the heat engines. So what is heat engines? Heat engines convert heat to work. So there are many types of heat engines in the world, but they are characterized by, first, receiving all heat from the high temperature source. For example, oil furnace or nuclear reactor. Secondly, convert some heat energy to work. Third, reject remaining heat energy to low temperature sink. So low temperature sink such as river, lake, and so on. And fourth, operate in a cycle. So from that we can see here we have a diagram of in our plant. So we have the boiler, which is the high temperature source. So energy source, which is used furnace. So from here, the system will gain heat from the energy furnace. The heat will enter the system, so heat Q in, and then some of energy will be converted into the work. So if is equal to work done, and the remaining heat energy that left in the system will be rejected by the system to the low temperature sink, so such as river. So heat is out from the system, so we can call it Q out. So W net is equal to W out minus W in. Okay, this is the, so we simplify this to this. So this is another diagram of heat engines. Source is a high temperature source, which is oil furnace or nuclear reactor. Heat engine is a system. Sink is literally the river or lake, which is system reject some remaining heat energy to the sink. and that's all. So W net is equal to Q in plus Q out. So Clausius inequality will determine either the cycle is possible cycle or impossible cycle, reversible cycle or reversible cycle. So that's all. Thank you. So this is a question for the Clausius inequality. A heat engine receives 6 kilowatt from a source at 250 degrees Celsius and rejects heat at 30 degrees Celsius with work done is equal to 0 kilowatt. So does this satisfy the inequality of Clausius? So as we know, the Clausius inequality states that for any possible cycle, the cyclic integral of delta q over t is less than or equal to 0. So from here, mathematically we will write like this: the integral of delta q over t is less than or equal to 0. So what Q stands for? Q stands for the heat transfer, and T is the temperature in Kelvin. So if the cyclic of delta Q over T is less than 0, so it will become irreversible cycling. So then we have cyclic delta Q over T is equal to 0, which is mean it is reversible, totally reversible, or internally reversible. So the last one is the condition is if the cyclic delta Q over T is greater than 0, so this will become the impossible cycle. So we must draw the diagram first. This is the first source, which is the heat engine will receive the heat from, and this is second source, which is the heat will go after that. So here is the work done on the. So the question we have 6 kilowatt. The engine receives 6 kilowatt from a source at 250 degrees Celsius. So this temperature we must convert it in Kelvin. This too in Kelvin. So and rejects heat at 30 degrees Celsius with 0 work done. So which means 0 done. So there is from the engine receive 6 kilowatt and rejects 6 kilowatt too. There is no heat loss due to the work done. So how to solve it? We solve using Q hot over T hot minus Q cold over T cold. So Q hot and T hot we can get from this. Q hot. Sorry, this is T hot and this is Q hot. This is T hot, T cold, sorry, T cold, and this is Q cold. So just substitute in this formula and find it whether is it less than 0 or equal to 0 or greater than 0. So substitute Q now 6 kilowatt over, so here we change 250 degrees Celsius, 250, we will get 5323 Kelvin. Then the Q cold is 6002 over, so 230 plus 273 is equal to 303, and then we solve it. 6000 over 5 to 3 minus 6000 over 303, so you will get minus 8.33, so which means this is less than 0. So this question satisfy the inequality of the Clausius. Satisfy the inequality of Clausius. Okay, that's all.